All right. So we're going to talk today about skimmer basin design for construction as well as post-construction. Real quick, my name's Jamie McCutchen. I am the principal founder of Rymar Waterworks. A 92 grad of Clemson University in civil engineering. Founded CCAD Engineering, which was a small civil design firm in 1999 that I owned until 2018. I invented the Marlee float skimmer back in 2013, and I'm a licensed professional engineer, South Carolina, North Carolina, and Georgia. Um, say all that just to let you know that this is intended to be a technical presentation. I've done, land development, stormwater related engineering for, I guess, over 30 years now, and hopefully can be able to provide some information that's helpful today. At that point, I'm going to cut off my video just because it does help with the recording. But if anybody has any questions, like I said, please use the chat feature, or if I don't see it, feel free to unmute yourself and ask a question. On today's agenda, we're going to talk about just a quick introduction to skimmers and floating outlets. We're going to look at basics of skimmer basin design. And then we're going to kind of pivot and look at using skimmers for post-construction. And we're going to wrap up with the Rymar water quality filter. First thing we'll do here, so I'm going to launch a quick poll. Excuse me, hit the wrong poll. And just ask, how familiar are you with skimmers? All right, so we've got most people have answered that. And today we've got about 66% are somewhat, but here to learn more. So we appreciate you joining us. 20% are new, and about 12% are very familiar with. So it just kind of helps me kind of understand our audience today. So, what we've done before skimmers is we had a perforated riser. You typically had some sort of riprap check dam or something in the front of it. And we water was coming out of it, typically from the bottom of the basin. So the whole idea with sediment basins is to allow time for the sediment to settle and go to the bottom of the pond. So it's not the best idea to be discharging from the bottom of the pond where that sediment concentration is highest. So skimmers have been around now for about 25 years. The idea is that the skimmer floats, drains the pond from the top down, releases that water that's near the surface or at the surface, which is, probably the cleanest part of the water column. The Marlee float skimmer, which is ours, is a little bit different than others in that it's releasing water from below the water surface, not directly on the surface. Advantage there is any floatables on the surface also get detained in the basin. So, typically you've got some trash and stuff on the top, then you got cleaner water, and then it gets dirtier as you go down. There are a number of skimmers available on the market today. The Faircloth skimmer was kind of the first one that's out there, probably one people are familiar with the most. Rotation Supply is similar to Faircloth. The IAS is kind of simple T version skimmer. And then you got the Marlee float, which looks a little different. There are a couple of others I've seen in this past year or so, had a couple of other skimmers come around, but it is something that's becoming a little more common. This little quick video, I'm not sure how many of you actually seen a skimmer sort of in action here, but this was about an 8-acre site, fully disturbed, had a really big storm come through. You saw the basin there, had a lot of trash in it, very, very sediment loaded. But this is the outfall from that basin just from the skimmer. You can see that water is actually much cleaner than what was in the basin. So the skimmer's doing a good job. This particular site was right near a lake. And so we were very concerned about having the lake turn red or brown and having, people with issues with that. So we did have some flocculants and other things downstream of this, but this flow was just from the skimmer itself. There's 3 fundamentals of sediment basin design I'm going to cover really quick. Number 1 is just basin volume. The volume is based on whatever the state standard is. So state regulations vary. The most common ones we see are either 1,800 or 3,600 cubic feet per acre flowing to the basin. Some areas also require basins to have a permanent pool or permanent volume for sediment storage that's not drained by the skimmer. The main thing we want to focus on here, use that required volume of the basin to size your skimmer, not the actual volume to size it. Also, typically do not include that sediment storage or permanent pool volume, just the volume that's going to be drained by the skimmer itself. Fundamental number two is dewatering time. Sediment basins work by allowing time for sediment to settle to the bottom of the pond. And so, it's important to give time for that to happen. The general standard we see is 2 to 5 days is probably the most common. Some states are 1 to 3. Some states, have other variations of that time. But just important to note, what that time is to make sure you're compliant with it. And number three is simply flow rate, which is simply the basin volume divided by the dewatering time to give you the flow rate. One thing we do recommend is that when you specify the flow rate, you specify that range as allowable. If it's a 2 to 5 days, then that gives you that flow rate of, that flow rate can be based on that 2 to 5 day range of time. What this does is if you specify a certain skimmer and a contractor says, hey, I want to use a different skimmer, well, does it fit that range? It's going to be much easier for the contractor to fit a range of time than a very specific time. Skimmers have different flow rates, not always easy to hit the exact same flow rate with different skimmers. This one is just a quick example to focus on the required storage versus provided. This was taken off of a set of plans. I believe the site was in Georgia. Engineers specified a 72-hour drain time, an 8-inch skimmer. He did specify a Marlee or other. The sediment storage required, which in this case is the required dewatering volume, 1,754 cubic yards. And that would actually need a 3-inch Marlee float with a 2.5-inch orifice, and that would be about an $1,100 product. The actual volume was 7,500 cubic yards, and that would need an 8-inch skimmer, actually with a 6.5-inch orifice to drain in 72 hours. That'd be about just under $6,000 product. So almost a $5,000 difference in cost for the contractor by using the required volume using the provided volume versus required to size the skimmer. More importantly, that 8-inch skimmer would drain that volume in less than 9 hours. And so if you've got a minimum time frame of of 24, 48, whatever that minimum time frame is, typically I don't think I've seen any that are less than 1 day. You're now not compliant. So it's important to base it on that required volume so that you're compliant with that drain time. Another quick poll here. I'm going to relaunch this poll. And so if you would just kind of let me know where you're located. We did something a little bit different when you signed up for this webinar. We had you answer a few questions. And so it looked like we had a lot of people from, I think, Ohio, Texas, and Georgia were our top 3 states. But who signs up and then who able to actually get on sometimes varies. So again, this will just kind of help me know who we have on with us today. So we've got most people have answered them in that, share the results. It looks like it's pretty evenly. Ohio is probably the highest single state. Got a lot of others. So those that have answered other, if you want to put in the chat where you're from, just to kind of let me know. We can kind of touch on any specific state requirements for those. So. All right. So because of who signed up and who the states that had said they were, I've included a couple of state standards today. So I'm going to start with Georgia. So one interesting thing about Georgia is when Georgia redid their erosion control manual back in 2016, they included some testing they did on skimmers. And because of that testing, they added this on skimmers that each product and each product size has a unique design and associated hydraulics, and the discharge rate is dependent on the specific product. And so it's important to use tested flow rates when you're doing skimmers. A couple of standards for Georgia. Their minimum volume, again, is 67 cubic yards per acre, which is at 1,800 cubic feet per acre. They require you to determine the elevation to get that. The main thing is they want this chart on the plans in Georgia. And so one interesting thing is they ask the time to drain. We recommend here to put in that range Georgia does not specify a specific time. They don't have a 1 to 3 day or 2 to 5 day. So we recommend establishing either a 2 to 3 day range of time. So say 1 to 3 or 2 to 5 or whatever you as engineer would like to do for that. But specifying that flow rate range will allow for equal skimmers to be confirmed quickly. Also, we had a good many from Texas sign up, at least in the response to the webinar. So Texas has relatively recently started requiring or actually enforcing the requirement for skimmers. So in Texas, they want you to, for the required volume, to base it on a 2-year, 24-hour storm or 3,600 cubic feet per acre drained. And then they also do have this, to utilize outlet structures that withdraw water from the surface. They do have a minimum time of 36 hours and maximum time of less than 72 hours. Again, primary outlet and spillway should pass the 25-year, 24-hour storm. Now that's going to be your skimmer and the riser structure. And again, they have that withdrawal from the surface unless infeasible. And they also include, that skimmers are dependent on the orifice configuration and used to manufacture flow charts, typically based on testing to determine the skimmer. On their design form, this is one thing that I've noticed lately. They have the total area drained basin as well as the total disturbed area. And on their basin volume design, they say the minimum required volume is the lesser of 3,600 cubic feet or that 2-year, 24-hour storm. So in this case, a lot of times that 2-year, 24-hour storm is going to be a larger volume than 3,600 cubic feet per acre. So by this standard, you would actually just use the lesser of that, the 3,600 cubic feet per acre. Also, we had a good many from Ohio, which was our #1 state today. So Ohio standards, they require minimum sediment storage volumes. This is not drains. So this is a permanent pool of 1,000 cubic feet per acre based on the disturbed area. And then you have an additional 1,800 cubic feet per acre total area for your dewatering volume. And the time frame is 48 to 168 hours. So 2 to 7 days in Ohio is allowed. Ohio EPA has a sediment basin sizing dewatering tool on their website. So you plug in to this tool both your total area and your disturbed area. Come up with those. You put in your pond stage storage relationship, so you can build in and make sure you've got the volume for your sediment storage zone as well as your dewatering zone. And then Ohio EPA includes multiple skimmer types in their tool. The Marlee float is one that is included in there, so important to note that it is recognized and accepted by Ohio and Ohio EPA and actually included in their design tool. So as I said, that was just a quick overview of a couple of states. Just to compare those, basin volume, like I said, varies. 1,800 cubic feet in Georgia, 3,600 cubic feet in Texas, and Ohio's 1,800 plus that 1,000 for the permanent pool. Some states have a surface area requirement or a minimum length to width ratio, or maybe a maximum depth. Principal spillway, usually we see that either the 2-year storm or 10-year storm designed for it. And emergency spillway, usually 25 to 100-year storm. Where skimmers are required, they are, in Georgia, they're still preferred. MS4s may require them. Texas and Ohio both say they're required over 10 acres. What we see as far as application of this is that if you have a riser structure, typically the state or local MS4 is going to require a skimmer. If you've got a sediment trap that's got a rock outlet, then typically they don't. Dewatering time, Georgia doesn't have a standard. I've got 24 hours in here, but really it's they don't really have a standard. Leave it up to the engineer. Texas is 36 to 72 hours, and Ohio is 2 to 7 days. So one thing that you may not know about skimmers, although we've kind of touched on some of the regs, is skimmers do have a flow rate curve to them. They're kind of thought of as constant head, constant flow devices. This chart was taken when TRI Environmental did some testing for the state of Georgia when they were updating their erosion control manual. They did 3 different 3-inch skimmers, so type 1, type 2, type 3, and they're all 3-inch skimmers. Their test tank is 4 feet deep. And if you look, 2 of them were very close, around 37 GPM, but one of them was nearly 70. at just a 1 foot depth. As the test tank depth rose from 1 foot to 4 feet, all three skimmers had about a 25% increase in flow rate with depth. Again, two of them were close, around 50 GPM, and one was close to 90. So important to recognize here, skimmers do have a flow rate curve. There is a change in flow over depth. Also, if you just spec'd a 3-inch skimmer and didn't give any more information, you may get one that flows at 50 GPM, or you may get one that flows at 90, which could, if you get the wrong one, either way, could put you out of compliance, could drain the pond too fast or could drain the pond too slow. So important to recognize flow rate when you're doing your designs. To help with that, we've got a simple Excel tool that we make available. This is free to download from our website. It gives you a block here to put your project and company information, a sediment basin description. Right here, we have this check. And so this was something we actually worked with Ohio EPA on. The most common mistake that we saw engineers make is that they were basing the skimmer sizing on the total volume of the pond versus the required volume of the pond. And a lot of times, if the pond's going to be a detention pond in the future, can be converted to a permanent pond, that volume can be much larger, 2, 3, 5, even 10 times as much volume. So this check here gives you required volume and your volume per acre to come up with what that required volume is. Then over here, you put in your time to drain, so minimum and max. Pond depth. Now, the pond depth is going to be the depth to achieve the required volume. If your pond's 6 feet deep, but you hit the required volume at 3, put in 3. Top length and width, bottom length and width. I know there are very few square or rectangular basins, so use your engineering judgment here. Adjust those as to within reason. Calculated pond volume, we recommend getting within about 5% of required either way. Again, you're trying to hit a fairly large range of time. Once you do that, the tool will calculate the flow rate and drain time for each skimmer with each orifice configuration. And then down here at the bottom, we've got the skimmer report page tab. Click on it. It'll take you to a nice, neat 8.5 by 11. You can include this in your SWIP or on your plans. The top of the page is going to have all your information. You're going to have this check right here to show that you base the skimmer sizing on that required volume. Going to give you the minimum flow rate for maximum time and maximum flow rate for minimum time. And then because it's our tool, it's going to tell you the drawdown time for each one of our skimmers with each orifice configuration. And based on the time you selected, will tell you if it's acceptable or not. So this example, I would probably go with our 2-inch with a 2-inch orifice, 69-hour time frame. That's kind of right in the middle of that 2 to 5 days. Plus, it's the least expensive skimmer. So good choice for this. But again, most sites, you're going to have multiple options of which skimmer orifice configuration to pick. And you as engineer are going to pick the one you prefer. We also have some sediment basin details. We actually have 4 different details. We have them for temporary basins without a riser structure, and we have them for dry and wet. So this is the version that is a riser structure that is a dry pond. So you got a chart here that's going to apply to all the basins on the site. So you may have a minimum length to width ratio or a maximum length to width ratio, that volume required, surface area requirement if you have one. And here's where you set your min and max dewatering time. So in this case, 48 to 120 hours is what we got on the plan. And then down here is a data block that's specific to each basin on the site. So obviously, a lot of sites have multiple basins. You can expand this as needed. So you'll have your drainage area, disturbed area, your flow rate, your basin volume. Again, just want to make sure that your provided meets the required basin surface area, provided and required. Then your pond information, outlet barrel, top of riser, etc. Get over here to your skimmer information, and you go skimmer size, skimmer orifice diameter, skimmer manufacturer, Rymar Marlee, hopefully is what you'll put in there. Is the equal allowed, yes or no? Now, most of the time, this is going to be yes. There are some situations where you may say no, particularly when we get into permanent, post-construction use. And then here's where you specify that flow rate range. So if you do allow equals and you put in that range and the contractor comes back and says, hey, got this skimmer left over from this other job, can I use it here? Well, it's pretty easy to figure out if it meets that range of time and if it's acceptable or not. We also provide our details. A couple of things about our detail just to point out. Number one, we have an orifice plate that we use for each skimmer. The orifice plate goes inside the body of the skimmer. and it controls the orifice, which controls the flow rate. Each detail has the tested flow rate information for each skimmer orifice configuration. The most common question we get is what's the length needed for this pipe between the skimmer and the riser structure? We and most other manufacturers recommend 1.4 times the height of the riser. This allows this pipe to be at about a 45-degree angle when the skimmer's basically at pond full or at top of the riser. So anyway, those are available as well to download from our website. And then last thing we've done here, this is we launched this earlier this year, is we have an online skimmer calculator. So you go in, you put in your basin name, you can put in your required pond volume, put in a range of time. Now, it is important to put at least some range in here. 2 to 5 days, 2 to 3 days, whatever you prefer. If you put in 2 to 2 or 3 to 3, you're not going to get a result unless it is exactly that time frame. So it's important to put in a range. Once you do that, it'll tell you which of our skimmers with each orifice fit within that range, what's the drawdown time for each one, and the flow rate. You as engineer pick whichever one you prefer based on that drawdown time and size. Hit the download button. It's going to take you to a nice, neat PDF. It's going to have all your basin information here up top, your skimmer size, orifice size, what that drawdown time is, flow rate of the skimmer, and the required volume of the basin, and the min and max time to drain. So you got all the critical information in place here for your skimmer detail. Engineers have found this is very useful, easy way to do it, and it's available in either PDF. I think we have a PNG file now too. So if you want, any kind of image file, whatever's easier for you. Also, if you prefer, on the website there's a CAD version of this, so you can just download it, put it on your plans, and then simply edit the box as needed for each project. Couple quick things here. This is a quick picture of a pond. Talk about skimmer installation. So contractor's done a good job. He's got the skimmer installed. He's tracked the sides. He's got his baffle up. But if you notice here, the stone pad was set in once the pond was graded. And what it did is it raised the skimmer up about 6 or 8 inches off the bottom of the pond. So this was intended to be a dry basin, but because of that, you're going to have 6 to 8 inches of water being held in the pond. We recommend, and on our detail shows a depression here, that just allows the skimmer to sit down as much as you can, drain the pond as fully as you can. Just something to be aware of if you have dry ponds in your area. And this is just probably just for information, the worst skimmer install we've ever seen. I'm not even sure how it's connected here. There's no flexible connection. There's only about 6 inches of pipe. And if you look close, that valve's open. So, unfortunately, sometimes contractors do contractor things and don't install them correctly. So anyway, just something to be aware of. So I'm going to stop and check the chat real quick. See if anybody has any questions before we go into post-construction use. So if you do have any questions about during construction or any other state questions, please let me know. Don't see any right now. Appreciate those that have joined us. See a couple of states. See a couple from Maine. We haven't seen a lot in Maine before, so appreciate you getting on today. Somebody asks, is the primary value you should see for skimmers during construction? So skimmers, from a regulatory standpoint, are primarily required during construction. Their permanent use of skimmers we're getting ready to talk about is something that is fairly new idea. The reason for that is a lot of skimmers are not suitable for post-construction use because they're made of PVC and just are not going to hold up for 20 plus years out in the outdoors and sunlight. So our skimmer is an HTP product. We have always intended it to be used for post-construction, but it's something that, if just be honest, if you're familiar with Faircloth and kind of, use that one, it's a PVC product. It's not going to last, longer than say 3-4 years or so, typically in a basin, because PVC does degrade in UV. So, all right, so let's talk about permanent use. Here, got one more poll I'm gonna try to get to come up. All right, so quickly, have you ever considered using a skimmer permanently? And I fully expect that to the majority be no, but I see at least one yes. That's great. I see a few that have considered. So we've got about 75% have answered, so we'll share the results. So about 80% have said no, which is really what we expect, and we're really glad you're on here with us this morning to talk about permanent use. About 8 have considered, and 2 have done it, so that's awesome. Every time we do this, it seems like each month we get at least a few more yeses and a few more in the considered. So for those that have not considered, let's talk about why you might want to do it. So number one, dry detention basins are probably the most common stormwater BMP out there. Wet ponds are probably right behind that. And then you get into all the other kind of, wet extended detention, wetland, bioretention, et cetera, et cetera. But, the dry pond is kind of the go-to thing. Typically with a dry pond, you've got the inlet located at the bottom of the pond, at least your first inlet. This is where sediment's going to accumulate, the most, going to have the highest concentration of sediment. And again, we're trying to provide water quality here, at least in most cases. So is it a good idea to discharge from where that sediment concentration is highest? Typically what we see is the skimmer is going to get removed once construction is complete. You're going to put some sort of low flow orifice down there, again, at the bottom, and you're going to size this to release that first flush volume if you're doing water quality with the first flush method. And you're even going to try to do something to keep it from clogging, right? A lot of times these first flush orifices can be really small. We've seen, 1, 2, 3 inch orifice sizes. Well, if you have a site that gets any kind of trash or just in the fall, some leaves or whatever, easy to get those clogged unless you do, a screen, a guard, perforated drain, something like that. If you were to look at your flow into the basin, at the inlet, you're going to have, a lot of suspended sediment. As it flows from the inlet to the outlet, that sediment is going to start to settle. And you're going to have that cleanest water is going to be at the surface near the outlet of the basin. So if your discharge is from this bottom area, you're discharging from where that sediment concentration is highest. If we could discharge from the top here, we're going to be discharging from where that area is the cleanest. And so if we're trying to trap as much sediment as we can and keep it in the pond and release that cleaner water, if we could find a way to release this water versus this water, it would be very helpful. So, as we talked about, basins rely on that natural settling. Skimmers release that cleaner water from the surface. They are now widely accepted and required during construction and proven to be very cost effective. So if it makes sense to use that for, method for construction, wouldn't it make sense to use it for post-construction water quality when, again, we're trying to release that cleaner water from the basin? So this little quick example of a skimmer being used for post-construction. So this is a pond, doesn't look like a pond, but not surprisingly, it got a notice of violation for failure to maintain the pond because, as you can see, it was severely overgrown and not functioning properly. Once the timber was removed and got some maintenance done on this thing, the outlet structure still wasn't functioning properly. It was holding water, and the best we could tell, it was supposed to be a dry pond. This was kind of upstream view of the pond. We got all the vegetation cleaned up. And what we found was there was a 2-inch orifice 6 feet below what is now the bottom of the pond. This pond's about 3/4 of an acre in size. It's 1.5 to 1 side slope. So just getting equipment into this pond to clean it out was going to be very difficult and expensive. And this was, like I said, back in 2013. So this our site was a recession victim. Just happened to be a client of mine was buying the property. And I told him, I said, go get your deal done to get the property. If you get that done before we go clean this thing out, let's see if we can redesign it. So we did. We went to the county and we proposed to put in a skimmer in place of the 2-inch orifice and redesign the ponds. You can see we closed in these orifices, added these. This was one of those rare ponds that actually had some excess volume available in it. So we were able to redesign it. And again, the existing outlet is a 2-inch orifice that is about 6 feet below here. So these are 6-foot riser sections. So there's an entire 6-foot riser section that is below what is now the bottom of the pond. So because skimmers had not been used for permanent use before, we were required to monitor this. This was done as a pilot project. And so We provided monthly test or inspection reports back to the county to make sure it was working properly. Then about a year or so later, the owner was now having a contractor come in and maintain the pond. So he had him go out and cut the sides. But as you could see before, it was very steep. All the debris, cuttings went down to the bottom, and they had a 5-inch rain in just a few hours before they could remove all that. Washed all that junk and debris down to the bottom of the pond. But you can see our skimmer kind of sitting here was able to drain it down even with all that debris there. They were able then to go clean it up and get it functioning properly again. You can imagine if this was a 2-inch orifice here at the bottom of the pond, that orifice would have been severely clogged. The depth here from the 2-inch orifice to the next orifices is about 8 feet. So just getting to that would have been a major challenge, very difficult, if not dangerous. So best firsthand example I have of how using a skimmer for post-construction, even without accounting for water quality yet, can help with maintenance and help maintain the flow of that pond and work properly. And you're going to get some enhancement of water quality because you're releasing that cleaner water from near the surface. So if you're going to model or going to consider that, you want to be able to model the skimmer. So most engineers we see use HydroFlow because it's now built into Civil 3D. If you use HydroCAD or some others, we'll be glad to help you with that too. But here's just kind of a quick example of modeling the skimmer in HydroFlow. So I'm going to skip over most of it, but just, first thing you do is build your pond. And so when you build your pond, you need to put in a stage to be able to enter the flow rate for the skimmer. So in this case, I built stages at 0, 0.1, 0.3, and then every half a foot up to 4 feet. This pond just happened to be 4 feet deep. You're going to then, doing that, the 0.1, 0.3, 0.5 marries up with the flow rates provided on the skimmer detail. So then you're going to go in, you're going to build your outlet structure. So you got a barrel here, 18-inch pipe in this case. This was a unique site in that it was a site that required quantity control during construction. So we've got a 6-inch orifice about just under 2 feet off the bottom of the pond. A riser structure has a rectangular weir. And then kind of the secret sauce here is this user-defined column. So this is where you're going to plug in your skimmer flow rates off the detail, off the testing data that we provide. So just plug that in 0.1, 0.3, 0.5, all the way up to 4 feet. Now I'll say I did every data point for this example, but in real world, there's not a huge difference in flow rate between half a foot and 1 foot and then 1.5. So if you decide to put in every foot, maybe every 2 feet, whatever you're comfortable with as engineer, but you want to build in that flow rate curve as best you can so that you've got the most accurate flow out of your pond. Now, what happens if your pond's over 4 feet deep, right? We've got a lot of basins that are going to be deeper than 4 feet, and you're going to need to be able to put in an accurate flow rate. So a couple of options. If you're just a little over 4, say you're 4 or 5 feet, maybe 5.5, you can just use this last user-defined rate because what we see on the flow rate curve, that flow rate tends to level off around that. You can extrapolate using the last 2 or 3 data points if you want. However, the most accurate way to do it is go back to our design tool that we showed you when we were doing the sediment basin design. In this case, put in your total pond depth. So let's just assume, let's say it was 8 feet. The tool is going to break that depth up into 20 different increments. So it's going to give you a flow rate at each increment. And then each skimmer is going to tell you that flow rate at each one of those increments. So then you can kind of look at this and pull off, say, the nearest half a foot or foot. For this example is our 6-inch skimmer with a 6-inch orifice. At a 4-foot depth, the flow rate was 0.784, and an 8-foot depth is 0.86. So not a huge difference, really just a tenth of a CFS increase. But when you're modeling for post-construction and you're trying to be really precise on your pre versus post flows, that tenth of a CFS can make a difference. So that's the most accurate way to plug that in, and then you can plug it in based on that incremental data. When you do that, going back to this specific pond that's 4 feet deep, you see the riser structure here in the schematics. We've got our 6-inch orifice, a rectangular weir, our riser. There is no low flow orifice here. Okay, that's your user-defined flow is that. But if you look at your stage discharge curve, that's the flow rate, for the user-defined. And then your other orifices kick in, as the pond gets deeper. So any questions on modeling in HydroFlow?
So it's not the modeling, it's the maintenance of the ponds, which is not being regulated by the local counties as well. I complained twice on my job sites about not being maintained, and they say this is not our jurisdiction. What the hell is that? Who has the jurisdiction of private ponds?
That maintenance is always a big question. It does vary from MS4 to MS4 as far as how they go about that. I know some MS4s now started, requiring maintenance agreements during the permitting process, so they establish who's responsible and put in some leverage, put in a hammer, so to speak, if that's not done, where the county or MS4 can do some enforcement. But it does vary widely, across states and even, from within states, from city to city, who does what, how they enforce that. I think that's something that is evolving and is probably going to improve, but it definitely takes time and it's got to be something the MS4 is willing to enforce. So.
MS4 stands for municipal storm sewage. Can you define MS4, sir?
Yeah, I mean, it definitely varies from MS4 to MS4. So I think that's a little different topic than we're on today, but it definitely
Yeah,
is something
I
that's very
know.
important.
I
Yeah.
understand that. But this pond was neglected for 12 years, and the
Well,
capacity
like
was
you saw in the
deleted.
example, the pond that we showed there was neglected for 25 years and or probably 20 years. And that's a great example of an MS4 um, putting in enforcement. So
What
in
does
that particular
MS4
case,
stands for? Can you give me MS4 stands for what?
municipal separate stormwater system. So it's a designation for who's responsible for the stormwater management within an area. So that can be a city, county, can be multiple counties, can be a variety of things, but it's what EPA delegates requirements to states, and then the states delegate the requirements down to the MS4s for local enforcement. So.
But in my area, the county is totally negligent. I can say that. I called them twice, says private part, but property we are not responsible for that.
Yeah, yeah. Unfortunately, there are some areas like that, and I think because of that, it's really important for engineers to design the ponds so they need as little maintenance as possible. Which is one thing that we do recommend. Skimmers can help with that. They often require less maintenance than some of the low flow outlets, so it can assist in that. So
Is the
so we're gonna
vegetation, or we can't control the vegetation, is a natural process.
correct. So we're going to switch now over to filtration based water quality, which is kind of the wrap up here this morning. So this is a pretty new concept. It's something that we've been pushing now for about a year and a half, 2 years. It's starting to see some acceptance of that, but we'll talk about what it can do. So we have developed a filter to go around our skimmer. And so the idea here is we've got an outer layer that's like a screen. So it's just a polyethylene fabric, it's a Mirror 5402 or some other woven geotextile we're using. We have an inner layer that is basically a polishing layer. So it's a non-woven material. We use a material called Absorbit. The material we use actually is treated, has an antimicrobial, so it's treated to potentially help with bacteria. They've got some testing to show it helps with metals. It'll absorb hydrocarbons. So, helps with a variety of things, including TSS, has really good TSS removal. And then the skimmer, again, is taking the water from near the surface and discharging. So the idea is that the skimmer pulls water through the filters in the top 3 feet of the basin. The filters generally are about 2 to 3 feet deep. And then if it's over that depth, we're allowing gravity to do the work where that sediment particle is not getting pulled back up to the skimmer to get discharged. So it's kind of a combination filtration, settling product, but it's been shown to be very effective, and our testing has gotten 90% TSS removal. So we prototyped this for over 2 years. So this is back in that same pond and we looked at before, and this was our prototype. This actually was probably our sixth or seventh prototype we're coming up with, trying to figure out how to do filtration around the skimmer in a pond. Um, and again, this prototype, it was basically a turbidity curtain with a screen in it. So it wasn't just a solid curtain. It had that screen in it. And then we had the non-woven on the inside. One thing about the non-woven is we didn't get enough flow through the non-woven initially. It was just it's supposed to have about 125, 150 gallon per minute flow rate. It just wasn't, water wasn't going through it. It was really just coming under. So what we decided to do was put in 2 layers of the non-woven, and we put in slits. So we do 6-inch wide panels. We offset those 3 inches, and we create a weaving effect of the water through the filter layer there. What that does is it gives more contact time on the fabric itself. And that fabric is what I'll call sticky. So it tends to grab sediment particles, what other polluted particles are in the water, and retain those versus letting them discharge. One thing it retained is it retained plant seed. So when we're doing our R&D during the spring and summer, we've noticed we'd start getting some vegetation grow in that filter. There may be some potential for nutrient removal if we can expand on this in the future. Probably going to need more vegetation than just what will grow there, but maybe we put this in the middle of a floating wetland or something like that, in order to get that nutrient removal. Again, we had this out there for about 2 years. This photo, you can see the turbidity outside the filter is a lot higher than what's inside. You can see a noticeable difference in turbidity here. And this is the outfall from that pond. So, fairly clean water coming out. So really minimal turbidity, minimal sediment in there. So we decided to have it tested by a third party, and we did. And we got over 90% TSS removal. It's important to understand the testing. So we engaged TRI Environmental to do the testing. Again, this is the same company that Georgia had engaged to do testing of skimmers for flow rate testing. You may not know it, but ASTM now has stormwater standards or sediment retention standards. So ASTM C1746 is a standard test method for sediment retention devices. So we follow that protocol. And one thing about this, your typical pond has a variety of things that impact how much sediment removal you get. You typically have a forebay. It's going to trap the larger particles. You typically have travel distance. You have a minimum length to width ratio. You may have vegetation or vegetated shelf, or you may be a wet pond that may help us on. So what we wanted to do is we wanted to test this under the worst case scenario. So you'll see here the sediment laden water in this photo is coming in about 1.5 to 2 feet from our first outer filter. So we're taking out the travel distance. We're taking out the forebay, putting that sediment in right at the basin. And then the tank was also set up as a dry pond to mimic a dry pond, so that the assumption is a wet pond is going to perform better than a dry pond. So we wanted to test it on that worst case scenario. And again, doing that testing, we got 90% TSS removal based on the ASTM test. We've now got our commercial version out in this basin. And so, this is basically what we've got available today. We've got a time-lapse camera set up on this, and we're keeping a close eye on it, watching it. It's been out there, I think February will be 2 years. So it's been out there since February of 2024 doing this. This is from the time-lapse camera. We had beavers invade the pond, so they built a dam around the outlet structure, but they didn't stop the skimmer from flowing. So even though the beaver, you can tell the filter's been impacted a little bit by the beavers, which would be unusual, but it does happen. But you can see the skimmer filter combination still draining this pond. The skimmer is sized based on the original 2-inch orifice flow rate. So we're just adding the filtration as an extra here. We're still doing the first flush method in this pond, but we're getting the benefit now of filtration in addition to the extended time for settlement. But you can see over the course of the day, skimmers draining that pond down at a good rate. So let's talk about some benefits to filtration versus settlement. Why would we want to consider this? So number one is your peak rate of discharge can be based on the filter treatment flow rate up to that first quantity storm event. This is going to reduce your pond size by 15% or more. So what we're saying is that instead of releasing that water quality volume at that flow rate over 24 hours, you can release it as fast as your filter can handle it, as whatever it takes, that flow rate is to do it. And all the filters are designed to keep up with the maximum flow of the skimmer. So when you release that water faster, you reduce the pond size. The filter is going to treat 100% of the runoff from the storms up to the peak rate of the filter. What we recommend is try to size the filter and skimmer to handle a 2-year storm event. So now you're treating up to a 2-year storm, not just that water quality event. You also are treating those really small storms. Under the first flush method, typically that's a 1.5 to maybe 2-inch storm event. What happens when we get a 1/4 inch of rain over 6 or 8 hours? Well, you're going to get the pollutants washed off with that rainfall, but you're not going to get enough water to create much ponding in your pond. And if the first flush method is based on ponding to allow time for settlement, you're not getting much treatment. But if you've got a filtration filter in there, everything's got to go through the filter. So you're treating those trickles up to that filter rate. You're also treating the water quality event, and you're treating the larger storm events if you can design the filter to handle those. And then your filtration media can be customized to target specific pollutants of concern. Like I said, we're already using media that helps with hydrocarbons, it helps with metals, may help with bacteria, in addition to TSS. Now, we've only tested for TSS so far, so I can't give you any removal rates of our system specifically, but I can give you removal rates of the media, what it will do, and you can kind of apply that as you see fit. So some additional benefits are that ponds provide a large containment area or containment volume, so you can reduce that maintenance frequency. There are other filter products out there, but they typically are in a vault or catch basin or something like that, and so they've got a very small volume for containment of sediment. This means they've got to be maintained more frequently. We've already had comments about maintenance here in the webinar today. So we understand maintenance is an issue. So if you can extend that maintenance frequency out to 5 years or 10 years because you've got enough volume in the pond to do that, your pond's going to function much longer. This is a big one. There's excellent potential to retrofit older basins that did not include water quality benefits if your peak flow rate can be maintained. So most of the time when you go back to retrofit basins, and I know we got people from Georgia on here, so we're working directly with Forsyth County in Georgia to try to find basins to retrofit, because there's hundreds, probably thousands of basins out there that were designed between the time we started looking at quantity events to this time we started looking at water quality events, which was really probably, depending on where you are in the country, anywhere from early 90s to early 2000s is when we first started looking at water quality. There's tons of basins that were built before that. You typically can't go back in and retrofit those basins because very few of them have excess volume to incorporate a traditional first flush model, just because it's not economically viable to do that. But if you can maintain that peak flow, now you can not change the size of the basin, but it also incorporate water quality. The thing is, filters and ponds are pretty easy to access and maintain. Again, kind of going back to that maintenance topic, but if you've got something that's in a vault or underground, it's kind of out of sight, out of mind, good chance it's going to be ignored and not maintained as well as something that's fairly easy to do a visual inspection and pretty easy to get to. So one advantage of using the system in ponds. So take that a step further from filtration to now using skimmers with filtration. So now you've got a flow control device. Your skimmer can be sized to control the peak rate for your lower storm events. Now, most parts of the country, that 2-year storm is that first quantity control event that we're trying to manage. Some places have a smaller storm event. They may call it different things, but in most places, 2-year storm is the standard. So if you can size your skimmer to be your flow control for the 2-year storm, that's going to be a good way to model it in the basin. Now the skimmer is going to increase the filter efficiency because we're now withdrawing from the surface where the water is cleaner. We could go down in and we could put a filter around a perforated drain or something in the bottom of the pond. Well, what's going to happen? Sediment's going to accumulate very quickly over that, and it's going to be, trying to treat the water that's got the highest sediment concentration in it. It's going to clog up very fast and need more maintenance. By attaching the skimmer to a filter, we're now raising it. We're treating that higher in the water column, towards the surface of the basin. So the filter doesn't have to work as hard. It's going to last longer. You can get cleaner water out of it. and less maintenance. And again, skimmer's pretty easy to maintain. You either pull it to the side, or if it's a dry pond, just let it drain down, and easy access for maintenance and changing the filters or cleaning them off. There are some challenges. Number one, filters are going to be prone to clog over time and will require maintenance and periodic cleaning or changing. We're currently recommending a 2-year time frame to replace the filters. That's just based on the UV, durability of the filter material and our prototype that was in the pond for 2 years. They've got to be durable, and they last more than the skimmer's got to be durable and last more than a few years to be suitable for permanent use. You don't want to have to replace the entire system. So if you're just replacing that filter fabric, much less expensive, much easier to maintain than having to replace the skimmer, the filter, the whole thing for there. Also, I didn't mention this on the slide, but if you're in an area with frozen conditions, you're going to need an alternate drain for those times when you've got frozen conditions. Now, I'm based in South Carolina, so I don't know much about this firsthand, I'll be honest. But what I've been told by folks in, say, Indiana, or Ohio or Minnesota, is that during the frozen time, you don't get a whole lot of runoff. But during that first thaw, it's very common for the pond still have ice on it, but you're still getting flow coming off the ground, going to the pond. So during that time, you're going to need to go out there, open up a valve with a perforated riser or something, and drain that pond from not the surface, from towards the bottom of the pond. And then the biggest standard, or there are no established standards for basis of design and permitting based upon a combination of a pond and filter. I'm sure we have some MS4 participants on, regulatory folks on today. I doubt very seriously if your manual mentions anything about how to design a filter with a basin. Haven't found one yet. If you do, I'd love to see it. We're in the process right now, in addition to our ASTM-based testing by third party, we are working on getting NJCAT approval. So we're working with NJCAT. If you're familiar with NJCAT, they have standard protocols for products. However, none of those products have ever been combined with a pond that we can see. So we're having to work very closely hand in hand with them about how we do our testing to make sure it meets the protocol that they can then verify and certify for us through their standard process. So hopefully we're very close to getting that testing done, hopefully in January or February, and by the end of the first quarter or so next year, have NJCAT approval. So, how does this site reduce your volume? So I ran a hydrograph or a model on a 5-acre site. And if we did the typical first flush method, for a 5-acre site, you're going to release that flow around 0.21, 0.25 CFS, depending on what that volume is, whether it's an inch, 1.2, 1.5 inches. But this was based on an inch, and you would need a storage volume about 0.245 acre feet for your water quality event. However, if you can design the filter and skimmer combination, and in this case, our 2-year storm rate was about 0.75 CFS or so. So our water quality event was released at 0.7 CFS. So you can see the hydrograph allowing more water out faster and reduces that storage volume down to 0.174. So about a 30% reduction in pond volume for that water quality event. And you've got the benefit, now you're treating everything to a 90% TSS removal all the way up to your 2-year storm event. So you're treating much more of that annual rainfall to do that. So those. And then I want to touch real quick on Georgia specifically. So we have had a number of sites in Georgia incorporate the filter for post-construction water quality. What we have seen MS4s accept currently is, rather than giving us the 90% approval or 90% TSS removal, they've said, hey, this is new. We want to kind of limit that. We're going to give you 50%. And we said, okay, we will accept 50%, because if you add a dry basin and the filter and you put those two together, you get the required 80% removal in Georgia. So if you're in Georgia, reach out to us, let us know what county, cities you worked with, and we can help you with that. But we've got a number of those that have accepted that. Once we get our NJCAT approval, I think they'll probably give us up to the 90%. but we have had multiple sites approved in Georgia using the filter. All right, so I'm going to do one more poll here and just ask, now that we've kind of gone over benefits of skimmers for post-construction permanent use, what's your thoughts? All right. I always get at least one or two still no's. They should be temporary, which I fully accept that. So we got about 60% or so answer now, something in that, share that. So we had three say no, should still be temporary. I fully respect that. And we got majority say maybe for the right project. I think that's the right answer, as well as yes, it's a good idea for the right situation. It is not a one size fits all, but it is a great tool to have in your toolbox. Got a question on there, Jeff. I'll come back to that in just a minute. So we'll wrap up here. Got about 4 or 5 minutes left. So real quickly, just want to introduce you to our website, rymarwaterworks.com, or you can go to marleefloat.com, Marlee. We have resources and training. So we have our webinars available on the website and through our YouTube channel. So like I said, we're recording this webinar. By tomorrow, it will be up here as well. We also have a training series. So we've covered a lot of information today. The training series takes a little deeper dive into each kind of section. So these are 5 to 15-minute videos that'll jump into a specific topic. For example, we didn't talk about SEDCAD today. So if you're in South Carolina, some areas of South Carolina, and I think some areas of maybe West Virginia, use SEDCAD. That's a sedimentology program. We'll tell you how to model a skimmer in that. So we kind of go through each one of those. Please check that out if you can help you with that. Mention our engineer spec pack or download. So this is our one stop. It's a zip file, just single download. You download it, you're going to get our skimmer details, the design tools, test data, maintenance recommendations, anything that you may need in your SWIP or that a reviewer would like to see. It's going to be a separate folder with sediment basin details. Like I said, there's 4 different details for that. And then there's a separate folder on the water quality. So it's going to give you the water quality basin details, design guide, test data, supporting information, everything you need if you want to put that into your project. Now, we do recommend, if you do that, that let us know what areas you would like to use the post-construction filter in. We'll be glad to reach out to those MS4s and make sure they're okay with it. Believe me, used to own an engineering company. Last thing I want to do is spend a whole bunch of time with a design, submit it, and then get told, no, I won't accept that. So we're glad to help you with that and kind of be the lead on that. A couple things about our product. It is an HTP product, polyethylene float, stainless steel or aluminum fittings. It is highly UV resistant. We'll call it virtually indestructible. If you hit it with a backhoe or something, yeah, it'll break. But we've seen a couple of people rip them out of basins with Tracos, and yeah, they didn't fare too well. But other than that, they hold up really well. They've always been intended to be part of the permanent outlet structure, and no moving parts, just a little pivot area. We've got this shielded orifice here. Again, ours is a little different. It doesn't take flow directly off the surface. It takes water in from below this debris guard. It traps the floatables in the basin, and mud and debris don't get to the outlet, so it's less prone to clog than most other skimmers, and it will work at least in mild frozen conditions. You're going to need 4 to 6 inches of ice before ours is going to stop working. We mentioned our orifice plate, so this is a little quick video to show this to you. So the EPDM rubber plate lasts long. It's got different size orifices to easily rotate. So you just take it out, twist it. Got this little metal nub here. It goes down over and it makes sure that the orifice is centered over the pipe going out. So really simple for contractors to change the flow rate on it. And then all of these have been third-party tested to verify the flow rates and drawdown times. We have 6 different models. We have our 2-inch goes down to a 1/2-inch orifice, only 250 cubic feet per day. That's just a trickle of flow. And we go all the way up to our 8-inch. And one thing to point out, we have 2 different 8-inch. We have our standard 8-inch. It uses a 6-inch pipe to connect from the skimmer to the riser. Everything else uses the same size pipe as what the skimmer is. And then we have our 8-inch with 8-inch pipe. We call it our 8-inch max. That flow rate is almost 2 CFS. So it's about double most other 8-inch skimmer flow rates. So if you've got some large sites, I don't know if we have any people on today that deal with solar sites. We've seen a lot of solar projects. Some of those basins are enormous. We've seen solar sites with a pond with maybe 6 8-inch skimmers. They were able to reduce it down to like 2 or 3 of our 8-inch with our 8-inch max skimmer. Much easier to install and save a ton of money for the contractor on that. And then, yep, that's it. Hit right at 12 o'clock. If you need a PDH certificate, I don't know if any of you that are on here because you saw my post, my Christmas gift to any engineers is a free PDH. Actually, we do that anytime, but we'll highlight that for Christmas. Just email us at info@rymarwaterworks.com. And then I'll be glad to answer any of the questions in chat. We do have one, any issues with animals, critters getting the system and impacting performance, especially more ecologically sensitive areas. So I'll admit the video I showed about the beavers getting into that basin, about 4 months later, they did get to the skimmer. So they were able to stop stop it up. We had to go do some minor maintenance. We're able to fix it right back. We're keeping an eye on it. They haven't clogged it up again since. So we deterred them, but generally no. I mean, it is something like we've talked about. Maintenance is a big issue, and you have to be aware of that. But pretty easy to visually inspect the skimmers. So if you have any other questions, I'd be glad to answer them. Otherwise, I hope everyone has a great holiday season. Merry Christmas, Happy New Year. And I would ask if I can, for a Christmas gift from everyone that's on, is you would consider on your next project specifying a Marlee float. That would be wonderful for us. We appreciate your time coming on, and hopefully we provided some good information. And if we did, we'd love to see our product on your plans. And if you're a reviewer, regulatory folk on here today, if you have any questions about our filter, please let us know. Skimmers, I think we've got approval everywhere. We need approval for skimmers for during construction. We've gone through different states and DOTs, and those are pretty standard. Our product's well accepted, no regulatory issues at all there. Post construction, everywhere is a little bit different, so we understand that. So if you're on here and you're on the regulatory community side, love to hear your thoughts on if this would be acceptable in your area, and that way we can kind of spread that word to engineers. So that's it for today. I'm going to stop the recording now.